Unit 2, Lesson 2. This lesson aligns with 14.5 in your textbooks. The one standard to discuss: choose trig functions to model periodic phenomena with specified amplitude, frequency, and midline. Some key vocabulary for this lesson. The first term, sinusoidal. This refers to the graphs of sine and cosine functions. Second term, amplitude. We can find the amplitude by taking the maximum minus the minimum values and dividing that by 2. The period refers to the horizontal length of one cycle of a periodic function, and the frequency is the reciprocal of the period. We have two general forms for sinusoids. We have one for sine and one for cosine. They're basically following the same key parts though. So we have y equals a times sine of bx plus c plus d, or we have y equals a times cosine of bx plus c plus d. Some of the key parts we just referred to: the absolute value of a is going to be the amplitude. If we take 2 pi divided by b, that gives us the period. If we take negative c divided by b, that's going to give us the horizontal or the phase shift. This term phase shift is probably what you're going to see most often with the Common Core standards. And the last part, d, is the vertical shift. Now we want to take the sinusoid and identify these 4 key parts. So we have y equals 2 times sine of 4x minus 2 plus 3. First, we want to find the amplitude. So we're looking at the number being multiplied in front of our sine function. We're taking the absolute value of 2, which simplifies down to 2. Next, we want to find the period. We find the period of this function by taking 2 pi and dividing that by b. The b value in this case is 4. So 2 pi divided by 4, which will simplify down to pi divided by 2. Remember, the period refers to the horizontal distance that it takes this function to complete one complete cycle. The phase shift, now we find by taking the opposite of c divided by b. The opposite of negative 2 is a positive 2 divided by 4, which reduces to 1/2. So we would shift horizontally half a unit to the right, depending on what our units are. In the last part, we want to identify the vertical shift, which is the number we're adding or subtracting at the end, which in this case is positive 3. In this next example, we want to write an equation for the sinusoidal with the given amplitude, period, and phase shift. We're just going to use the sine function. We're told the amplitude is 2, the period is pi, and the phase shift is 1/2. To start out our equation, we have y equals, our a value is 2 times sine. Now we need to identify what our b and c values are going to be. So off to the side, we know the expression for the period is 2 pi divided by b, which is equal to pi in this case. So now if I multiply b across to the other side, we would have 2 pi is equal to pi times b. And then to get b isolated by itself, we divide both sides of the equation by pi. Thus, we get our b value is equal to 2. So over here, we know our b value. Change that back to the correct color. The b value is going to be 2. Now we have to use that information to identify what the c value is going to be. We know that the expression for the phase shift is the opposite of c divided by b is equal to 1/2. And we know b in this case is equal to 2. So the opposite of c divided by 2 is equal to 1/2. If we multiply this 2 to the other side, we get that negative c is equal to 1, which implies that c is equal to -1. So to finish off inside the parentheses, we would have -1. We weren't told anything about a vertical shift, so this is our sinusoidal function with the given amplitude, period, and phase shift. In this next example, we want to use the graph to write an equation for the sine function. Starting out, the first thing that we can quickly identify is the amplitude. Okay, our midline is the x-axis. So from the x-axis, we're going to a maximum of 2 and a minimum of -2. So to go from this midline to the maximum is 2 units, or to go from the midline to the minimum is 2 units. Thus, the amplitude is 2. So starting out our equation, we have y is equal to 2 times sine. Now we need to identify what the b value is. So the expression for the period is 2 pi divided by b is equal to the period, in this case, how far it takes to complete one cycle. If we start right at the origin, we go up, down, and end. This is one complete cycle, that's a period, and that is from 0 to pi. So we know the period's equal to pi. Now if we solve to get b isolated by itself, 2 pi is equal to pi times b. And just like the last problem, we simplify and get a b value of 2. So inside parentheses, we have 2 times x. Now we would look and see if there's any horizontal shift. If we're starting at the origin with the sine function, that means there's no horizontal or phase shift. We're not shifting up or down, there's no vertical shift. So this is the equation of the sinusoidal. The last example, we want to write an equation for this cosine graph. First, we want to identify the amplitude, which is going to be more difficult in this case because, as you can see, we have some sort of vertical shift going on. So to find the amplitude, we have to take the maximum minus the minimum value and divide that by 2. So our maximum value is 1 minus the minimum value of -3. So 1 minus a -3 is 4. 4 divided by 2, the amplitude in this case is 2. So to start our graph, or our function, we have y equals 2 times the cosine of, now we need to identify what our b value is. Our expression for the period of a function is 2 pi divided by b, which is equal to, now we have to identify the period. So if we start at 1, go down, complete one whole cycle. So to go from 0 to 4 pi, the period in this case is 4 pi. Now multiply across, we would get 2 pi is equal to 4 times pi times b. To get b by itself, divide by 4 pi, divide by 4 pi, which is going to simplify to 1/2. So the b value in this case is 1/2. 1/2 times x. Now we want to look and see, is there any phase shift, horizontal shift left or right? Cosine function, we're always starting at our maximum value, so there's no phase shift in this case. Now we want to look, what is the vertical shift? In the beginning, we determined that the amplitude was 2, which means our maximum value would occur at 2 if this had no vertical shift. Well, since our maximum value occurs at 1, we simply have to take 2 minus 1. We have a vertical shift down 1 unit. So at the end, we have -1. This is the equation for this particular sinusoidal. We just went through a lot of information. What I want you to focus on is the amplitude and the period, as well as identifying these 4 parts of the graph: the amplitude, period, the phase shift, and the vertical shift. We're going to go through more examples together in class, but make sure you have a basic understanding of how we identify and find these A, B, C, and D values.